So can anybody confirm? Is it presentation?
Yes, sir.
Yeah. Okay. Thanks. Okay. So we have seen when the electricity came into our lives, and we have seen what are the various causes which leads to accidents. Then we have seen different types of hazards and what will be the impact. Again, now we'll see uh, further. So basically, the injuries are possible without an current flowing through the body. Example, burns due to the electric arc, and also radiation and even electromagnetic field, or falling or injury due to sudden starting of machines or equipment. This is how the injuries happen, even though you are not current not flowing through the body. And if you see the some of the precautions, using of proper fuses, switch gears, and circuit breakers, earthing, bonding, and such electrical safety precautions are highly needed to prevent the accidents due to electrical hazards. Basically, using proper fuses, switch gears, and circuit breakers, earthing, and bonding. So when I say bonding, it is purely for uh, static electricity. Now we'll see some of the statutory provisions. So as per the Factories Act, which is applicable throughout India, and under 37 section speaks about a portable electric light less than 24 volts, and section 37 requires effective enclosures to sources of ignition, which includes frame-proof electrical fittings. So the 24 volts will be to avoid the generation of the heat, so that if you use a 24 volts bulb, it will not generate more heat, which can, even though the chemicals having a low LEEL limits, a lower explosive limit, or it not able to ignite the hazardous atmosphere. Then comes to IS, which is Bureau of Indian Standards 5216, Guide for the Safety Precautions and Practices in Electric Work. There we have part 1 and 2. 2 will be talks about the life-saving techniques. So where it talks about the maintenance part. And also we have SP30, National Electric Code, which is compiling many IS and also electro technologies, and SP31, it is about the treatment of electric shock, etc., etc. There are few more national electric codes with respect to handling and the usage of various electrical hazards and equipments, etc. Then we'll see the effects of electrical parameters on human body. So when we say parameters, the units, which is especially amperes for the current, will have another unit voltage, where it will act as a driving force to carry the current. When we see the first major hazards due to electricity is a shock to a person, and it is the current, not the voltage, that causes physical damage. So voltage, it is simply putting it in it is a kind of slope. When we take an example of water, so what will happen, wherever it is the water, wherever it is the slope is there, it will have less pressure, so that the water will go on a downfall. Same way, because of the imbalance or the difference in the current, the voltage will takes from higher side to the lower side, that impedance difference. So here the current only gives an impact when electric shock occurs. But sometimes the voltage also matters, because it is in a driving force. If the less voltage, you will get the current will pass a lesser. When we say high voltage, the amount of current it carries higher. So basically, it's work on the potential difference between the two ends, the voltage. Even blood is also a good conductor of electricity, but the skin is highly resistive. So why it is blood is a good conductor? The blood is a good conductor because of presence of dissolved ions. Like in our blood, we have potassium, calcium, chloride, etc., etc. Because of these ions, will allow the electrons to move, the free electrons. That's why the blood is a good conductor. But skin, it is act as an insulator. When it is punctured, whenever any incident or if you're having any injuries on your skin, then there is no more current will flow through the body. Unless the skin is punctured, the current will not flow. That's why whenever any electric shock happens, if it is in a high voltage, it will burns your skin, then you will get in a shock. But it happens in a fraction of seconds. You will not see that, okay, the skin will burn for some time and then you will get a shock. It will everything will happen in a fraction of seconds. Initially, it will damage your tissues, then you will get the shock. Body resistance of each person is variable, which means it will differ. Therefore, the effect on them is also variable up to 10 milliamperes. The current can bear with pain, but at 30 amperes, chest muscles do not work, breathing stops, and also death may occur eventually. So up to 10 milliamperes. I think if I'm not wrong, the leakage of 0.25 ampere is dangerous for human life itself. 250 milliamperes causes complete death. 0.25 amperes, which means the same, dangerous to human life. Sometimes after effects are more severe than the actual shock or burns. So we should be very careful the appliances which we are using in our home as well. And we should always cross-check the electrical cables and plugs. Sometimes we directly insert the bare cables without a plug into the sockets. It is also dangerous. Sometimes we try to put the plug holding near the conductors. It is also very dangerous. You have to hold the plug properly while inserting in the socket. The electric shock is an effect of the current which is flowing through the nerves, muscles, heart, or of other organs of body. The shock is sudden and also accidental stimulation of the body's nervous system by electric current, which flows due to the voltage difference. As I mentioned, voltage difference is the flow difference or the pressure difference in a simple language. It tends to move the lower side. Again, the current may be two types majorly. They are DC and AC, direct current and alternate current. DC maintain involuntary grip and also live conductors, which prolong the current flow, and therefore a victim needs to be separated by a non-metallic rod or device. And more DC is required than AC to cause the same effect. So AC is more dangerous than DC, but DC will have the hold on effect. So where it will tends to hold you for a longer durations because of the muscle contraction happens. But AC, it is an alternate current. There will be this kind of impulse will happen. The return current will pass through the neutrals. The phase where will carry the current, the same current will come back from the neutral cable. So in case of any interruption in the between the current difference, so we will have the device like ELCBs or RCCBs to cut down the supply. Whenever difference comes, in case of leakage, any earth leakage or somebody involved in the circuit, there will be a difference between return. So the return current difference will detect by these circuit breakers, then immediately cut off the supply. And AC produces fibrillation every cycle, where DC produces only once. So this fibrillation happens every time because it is kind of a loop, so that it gives every fibrillation for each cycle. That's why AC is more dangerous than DC. So as I mentioned, low current disturbs the body rhythm and sometimes stops the heart if the time duration prolongs, but high current causes electric burns and sometimes death. So rhythm in the sense, rhythm will change of our heartbeat, and sometimes it will due to that rhythm change, sometimes it got struck, then your heart will stops. Then DC current, and sometimes it is in a high side, the current will cause immediate electric burns and sometimes death as well. Maybe you would have seen the people will burn into ashes And shock may be happen due to these reasons: contact with the bare live conductor. When I say conductor, what is mean by conductor? Conductor, insulator. Yes. Yeah. Yes. Your voice is not clear.
The flowing of current, sir.
Okay. Yeah. Basically, conductor is allowing the current to pass. Basically, it will have the free electrons. It will pass the electrons to move from one end to other end. When you say removal of insulator, it will not have any free electrons in that, so it will not allow the current to pass. When I say good insulator, when we say a dry wood and also rubber, plastic, in these materials, there will not be any free electrons. So those materials will act as insulators. When I say conductor, it will allow the electrons to pass there. The current will go from one end to other end. Then short circuit due to the sudden failure and also short circuit current not going to the earth but flowing through the human body. When you see human body, it is going to be electric shock. Then static charge on equipment discharges through human body. Then lightning. Lightning, it will be because of the weather condition during the rainy season. We used to have this the difference, and also the it is also in the static electricity which generates due to the friction and also between the clouds and also air. Then earth will be act as in a highly positive charge, so the negative charge will, because of charge difference, it will discharge like as a thunder. So when I say the current ranges or the units, I have this is an example of if a average person of 68 kilograms, men, so the current units 50 hertz, 1 ampere, so nothing will happen. Then only 1 ampere precision threshold, in the sense we can able to hold it. I mean, we can able to bear it. 1 to 3 amperes, a mild sensation. Then 3 to 10 amperes, painful sensation, and 10 milliamperes, paralysis threshold of arms. So you'll not able to move your arms, cannot release the hand grip. So that is the hold on type. When you are when we are become a part in that 10 milliampere circuit, so you will be can't able to release your hand grip. Then 30 milliamperes fibrillation threshold, then stop breathing, most frequently fatal. And 75 milliamperes, again fibrillation threshold 99.5%, and the heart action discoordinated, probably fatal. So discoordinated, the breathing pattern, the heart rhythm will change. It will increase, then suddenly it stops. Then 250 milliamperes, so fibrillation threshold is 99%, and heart and blood circulation may stop, definitely fatal. In 75 milliamperes, probably sometimes it may not result as a fatal case. Sometimes you can save also, but if you're exposed to 250 milliamperes, definitely it will be a fatal. When I say fatal, it is a death. Fatal accident means a death case. Then we'll see some of the distances. As we seen in the video also, the excavator which is passing underneath to an electrical cable, I mean bare electrical cable, it's been involved in the circuit. So it is obvious that overhead electrical lines should not be allowed in a place where the public or public vehicles have to pass through the most of the time, and not at such a low or unsafe distances, clearance above the ground, so that the chances of touching the lines may increase. Therefore, some of the minimum distances from these lines are necessary. Even you would have seen in your along the street. So when you say in the where the societies or publics where we live. Around the street, we'll have the bare conductor, which means the aluminum cable. Over that, they will put the plastic pipes. If the cable is very close to the buildings, they put this plastic cables to avoid any accidental contact or any involvement of in that induction or electromagnetic field. When we say the rules, there are 77 to 80 of Indian Electricity Rules 1956 provides the safe distances from this cables. So if you see, I have taken the example here. Across the street, the medium voltage lines are 19 feet and high voltage will be 20. And along the street, 18 and 19. And elsewhere up to 11 kV, 15 feet or 11 kV insulated. First is the bare one, insulated 13, and bare wire without an insulation, it is 15. And following other units. Anyhow, I'll give this presentation, you can refer later. Then, wherein again the overhead line crosses or it is in a proximity to another overhead line, the minimum clearance, which means 1/1. So if you see in the big towers, electrical towers, where you have different systems or different voltage levels, you will see from like 11 kV, 110 kV, 32 kV, etc. So these are the some of the distances they should maintain 1/, or between the two conductors. Again, the safety precautions, we'll see what kind of safety precautions we have to take to safeguard ourselves. So let us comes to safety precautions, the earthing and double earthing. So general earthing for a big power station is up to 0.5 mega ohms. So why we need to have earthing? Any guess? What is the importance of earthing?
Static, sir. Static generation.
Okay.
Static generate, not generated, sir. That's why connected to properly connected to earthing, sir.
Okay. If it is not connected, what will happen?
It's direct flow of body, sir. Body to earth.
If somebody touches any equipment, if not earth the conductor or the body, what will happen? We will become a part in the circuit. We will get the electric shock. Okay.
Okay.
So when I say general safety precautions, use of approved insulated tools and rubber mats, shock-proof gloves and boots, tester or fuse pullers. Tong is nothing but how you can sometimes we use it is a kind of stick where it will have a fiber or sometimes insulated stick where we use pull the cables, and sometimes we use to pull the persons if somebody involved in electric shock, and discharge rod, safety belt, hand lamp or wooden or insulated ladder, not wearing any metal rings or chains while working with this electrical cables or electrical works. And switches on the live lines, fused switches and air current breakers should be used. Avoid temporary wiring and avoid hurry and chance taking. Avoid left hand touching, because left hand touching, our heart is in the left side. In case of any incident happen, how the circuit will flow from the left hand. Again, it will go to the through the foot if you're not using any insulated shoes, or if you're directly on the earth. So it will directly discharge from your left leg, most probably. So in that case, there is a most probability of the current will pass through your heart. So that's why always avoid touching with the left hand. And qualified and also trained electricians. So whoever is electrician, they are trained electricians so that they'll know how to handle the electric current. Then low voltage 24 and also 100 voltage is hazardous area, and good insulated and tested wiring, installation of machines equipment before usage. Then work permit system, as I mentioned, IS 5216-1699 flows this electrical work. So how to handle the electrical activities. So definitely, in case of any electrical work is happening, we have to follow this work permit procedure and use the safety tags and warning notices. Safety tag and warning notices, it is nothing but LOTO, lockout and tagout system. As we seen in the video, whenever a multi-team or multi-departmental team is involved in a single equipment, everybody should have their own tag and their own key with them so that we can avoid the accidents. Then use of mission equipment with their limits and no overloading. Placement of oil type transformers outside and auxiliary room, battery room and control rooms to be separated. 2 exits in each electric room for the escape in case of any short circuit or any arc flash incident happens. And the switch gear of the supply the company should be separated from the consumer by a fireproof wall to avoid the spread of the fire accident. Then generators and motors with a fireproof doors automatically actuated by the fire detectors and ready use of CO2 type fire extinguishers, especially for this electrical short circuits. If you use another water or foam type, there is a chance of electric shock. If you use any powder type fire extinguishers, in case of any sophisticated equipments like any motherboards or any data storage centers or any sensitive equipments, there will be a chance of damage by reacting with this extinguishing media. So always preferable to use the CO2 carbon dioxide fire extinguisher for the electrical short circuit. If it is not possible, it is not available in the immediate vicinity, so you can use the powder type. And double communication system with the critical areas. Then clear approach available for the firefighting squad. So approach in the sense, the availability of space. Sometimes what will happen, these electrical rooms have been used as storage for the spares or any damaged or sometimes they use cables and something extra, I mean, which are related to maintenance only. They used to keep in these electrical rooms. So it should not be. So we should have the minimum clearance of 1 meter and 1.5 meter in front of the panel and 1 meter in the backside of the panel so that we can have a clear access to fight against the fire. And flame and shock detectors and central fire annunciation system for the fire safety. It is nothing but again detection and control system. A diesel pump set for the required fire water pressure. Again, it is for in case of any fire accident happen, definitely will cut off the supply. So then the diesel pump should be in active state and good working condition so that it can help us to pressurize our fire hydrant systems. Good housekeeping, including a well maintenance of all electrical insulations. So in case of an insulation damage, it should be rectified immediately. And adequate working space and means of access around each apparatus. So to take any equipment, you should have sufficient space in and around the equipment so that you can work properly. First aid boxes and respiratory equipment ready, training for artificial respiration to save the life from the shock. So when we say artificial respiration, so CPR, so the people should train on first aid in case of electric shock happens. So how to treat that person in case of burns happens, in case of electric shock happens, in case of any he is not breathing or he became unconscious. So when we say person become unconscious, so immediately we have to start giving CPR, cardio pulmonary resuscitation. So in a sense, we used to. Any question?
No, sir. No, sir.
Okay, thanks. So when we say CPR, we used to give the 30 chest compressions and we'll give 2 air blows so that we can try to activate the rhythm of the heart. So it will give a blood flow to the heart so that it can start again. Then prevent higher humidity and temperature near the electrical installations, work with full protection in raining, use of flame-proof and explosive-proof equipments in flammable and explosive areas. So we have a slide in the last. We'll see different types of flame-proof electrical fittings as well. Earthing and bonding for the solvent carrying pipelines and equipments. Now we'll see the types of protection. When we say capacity and also protection of conductors, point and connectors. Conductors in conduit, so it is nothing but an electrical cable. Conductor is nothing but the copper cable which you see inside the cable. The conductors in flexible metallic tubing, conductors in metal trunking, conductors in metal sheeting, cables in trench. These are the various ways we'll try to protect the conductors from the damage. Even if you see the bus bars and all, these are completely packed with aluminum sheeting. Then overload and short circuit protection. Again, here we use the fuses, relays, and circuit breakers to protect the overload, and it should be of a sufficient braking capacity to prevent the safely at the short circuit currents. Arcing and scattering of hot metals. Metal of the fuses may be prevented using improved fuses of cartridge or any other type having special arrangements for extending of arc and reducing the current values. Then ELCBs, these are very famous, ELCBs and RCCBs, earth leakage circuit breakers. So basically, these ELCBs where it is not practicable to obtain any low impedance, and wherever the protection is afforded by the overcurrent fuses or circuit breakers along with the earthed or conductor is not adequate, a leakage protection can be achieved. This is kind of leakage protection. In case of any leakage happens from the flow. So when we say leakage, the leakage may happen because of any damage or insulation damage, the power which we have supplied through the machine or an equipment, it will go to the earth. Or sometimes if the person is touching the same equipment, he will also become a part of the circuit. In case of such leakage happens, the return current will not will be reduced. So it will ELCB will detect that return, then it will activate the activate in the sense it will cut off the supply. So basically, the abnormal conditions will be the leakage occurs due to the insulation failure or any person touching the live wires, or sometimes even the current flow through the ground instead of returning through the neutral. This ground means again it is also a leakage. So when it is not returning from the neutral, in the sense something is going out of the circuit. So basically that it creates the imbalance in the circuit. When it become imbalance, automatically the ELCB will cut off the supply. Then no load protection. So when I say no load protection, it is also very important. So over the current condition is generally known as overload condition. So over current condition in the sense you're drawing more than the capacity of the conductor or the cable which you're using. It should be protected by equipment which will operate at excess or more than rated or current and stop the supply. Similarly, low current or low voltage condition is said to be a no load condition, and it is need to be protected. When I say no load, here I've taken an example. A simple running of electric motor without rotating the pump, a generator or machine shaft is known as no load working condition. A motor is running, but it is not giving any output. Only simply the motor is running. It is not connected to any activity. It is also should be protected. And we have some more precautions. One is, as mentioned, employ trained electricians and give them full information regarding the possibility of arcing and fuses. So handles of switch and fuse boxes should be insulated, and leather hand gloves or rubber hand gloves, elbows should be given to the workers. And no load protection or precautions against accidental contact is also necessary. At no load, no more current is desired. Therefore, low current rated fuses are to be selected. If this load is not there, you should choose the current which is required for the load, and then we have to choose the same rated fuses. If the current is low, if you are using the fuses or the breakers in the higher side, so again it is a problem. It depends on how much current which you are using at the no load condition. For the same amount, you should have the breakers so that it can safeguard the person in case of he is involved in the circuit. Fuse box covers the should have small apparatus to introduce the end voltage tester to ensure that the contact of the live or not. And the box flash proof cover should be such as that it is opened, it will stop the current. So these are the sophisticated equipments. When you open that, it will automatically switch off the supply. Then earthing standards, as I mentioned, again, we have an Indian standard, IS standard, it is 3043, code of practice for earthing, even SB30, National Elective Code, which is referred for the detailed earthing. And when we say the purpose of earthing is to protect the equipment from the danger to the life or risk of fire due to the leakage of current through the metal work and also through the person in the contact. When we say earthing, one is for protecting the equipment as well as people from the leakage current which is going from the circuit. Okay, again, a lockout and tagout. This is also a most desirable practice or most important practice. Everybody should follow. Even if you say in home, sometimes with the overconfidence, we try to do some things without switching off the main supply. Even though we have individual MCBs for the each room or each socket or the board, but it is always good to shut off your main input supply when you are doing any corrections or activities in your home as well. So when I say lockout and tag out and test out, there is another TO, low toe. So lockout and tag out, so we'll be locking all the energies. It is not about only electricity. If you take any different equipments, will have different types of energies which is connected. Chemical, mechanical, even the positive side, the battery energy, stored energy will be there. Then in case of if you see any other different types of energies will be connected. So we have to identify all the types of energies which is connected to that equipment. Then we have to isolate or we have to drain the energies. Then we have to lock. Then tag will be who has done that lock and his contact number, so that in case of any necessity, they can reach you out. So lockout and tagout are generally industrial practices indicating a warning that the equipment or machine is so locked or tagged, tagged out, shall not be used till that the lock or notice is removed. So it indicates that somebody is working on that equipment. So until unless the lock and tag is removed, we are not supposed to use that equipment. Lockout means making the equipment or machine inoperative or power isolated so that it cannot be started or used. So when I say lock, it means you made inoperative. You are not allowing to run that equipment. Unlocked label or notice or lockout indicates that the equipment or machine is faulty, under repair or maintenance, and is locked for the purpose of not using it till the lock is or notice exits. It means if you are putting in a locked label, maybe because of damage, the machine is not working, it is faulty, or somebody is doing some maintenance activity on that equipment. So it indicates others are not allowed to activate that. So when we say a procedure, of this lockout, it should be established and also should include. So procedure in the sense, every company should have their a lotto procedure, how to do an lotto, and how to practice it. When I say the procedure before locking or tagging, inform the concerned operators and users that the line, switch, valve, or equipment will be isolated or de-energized, and give them time to complete or stop their work. Okay, whenever you are doing any lock. So, okay, here we have less than a minute. I will explain this point and we'll have continuation in tomorrow. So whenever you are doing any lock or tag, so you should inform to the user. For example, if you're using lock for any specific equipment, you have to go to the current shift mission operator. You have to inform them, we are switching off this supply. We are going to lock for the so and so reason. So definitely you will have the permit. Then you should take signature of that person as well, so that they will be aware. So you are going to switching off the supply. You are going to de-energize the supply. Once you're done, again you will back to inform. That is the last step where we do in the